This is SpaceTime, Series 24, Episode 52. Coming up on SpaceTime, another out-of-control Chinese spacecraft crashes to Earth. The Ingenuity helicopter begins a new demonstration phase on Mars. And solving the mystery of the length of a day on Venus. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
People have once again faced a major threat from an out-of-control Chinese spacecraft. The problem this time was the massive core stage of the Long March 5B rocket, which last month launched the first module of China's new space station into orbit. After delivering the module into its 380-kilometre high orbit, the 30-metre-long rocket segment should have undertaken a controlled deorbit burn, placing itself on a re-entry track that would have sent it into a remote part of the southeastern Pacific Ocean known as Point Nemo, an uninhabited location with no shipping or airline routes. Instead, Beijing left the giant 22-ton booster tumbling wildly out of control. Harvard astronomer Jonathan McDowell summarized it best on Twitter, saying that this was not an accident, but poor rocket design. The Pentagon, which was tracking the madly spinning booster, admits that it's impossible to determine where ground zero for the Long March 5B will be until around 90 minutes before impact. That's because it all depends on how atmospheric drag decays the orbit, so scientists really only know it's going to be on its final orbit when it's already on its final orbit. Dr. Brad Tucker is an astronomer with the Australian National University's Mount Stromlo Observatory.
And the problem is, people would like to say, well, it's going to happen at this exact time and location. We would like that too, but it's uncontrolled. And when it's uncontrolled, that means that we don't know exactly the angle it's hitting the Earth's atmosphere, and it's the Earth's atmosphere that produces the drag, that slows it down, that falls back to the Earth. And the Earth's atmosphere itself is really hard to model at this level of detail and changes. That changes daily, sometimes by the minute. Solar activity can actually change the Earth's atmosphere. So all these things mean we have some uncertainty.
It really wasn't until the final orbit that they knew for sure where it was going to come down and when it was going to come down, because it kept bouncing off the atmosphere and doing one more orbit, and then finally it decided not to bounce but tunnel through.
By design, everyone wants these to land in the South Pacific Ocean. That is the goal because it's the most remote or uninhabited place in the Earth. And in fact, lots of these pieces of debris have landed there before. But when you're uncontrolled, you can't guarantee that.
Orbital mechanics meant the Chinese rocket would hit the Earth's atmosphere at almost 28,000 kilometres per hour. And its orbital trajectory meant it would crash back onto the surface somewhere between 40 degrees north and 40 degrees south of the equator. And that places most of the world's population in its crosshairs, including many major cities from New York to Los Angeles, Sydney to Melbourne. It eventually crashed down in the Indian Ocean on Sunday at around 12:24 Australian Eastern Standard Time, that's 2:24 in the morning Greenwich Mean Time, slamming into the water near Dalu Atoll in the Maldives archipelago. An official statement from NASA shortly after the impact said China was failing to meet responsible standards regarding their space debris. NASA says spacefaring nations must minimize the risks to people and property on Earth of re-entries from space objects and maximize transparency regarding those operations. The agency says it's crucial that China and all spacefaring nations and commercial entities act responsibly and transparently in space to ensure the safety, stability, security, and long-term sustainability of outer space activities. The bottom line is, sheer dumb luck is all that stood in the way of a major disaster. Now, if all this sounds a little bit déjà vu, that's because Beijing's done this before. Just 3 years ago, in 2018, China lost control of its Tiangong-1 space station, which eventually crashed back to Earth just northwest of Tahiti. Beijing had lost contact with the school bus-sized prototype space station 2 years earlier, but they didn't bother telling anyone or asking for help until other nations detected its orbital decay.
Tiangong-1 when it crashed. It ended up over the Easter weekend a few years ago, about 100 k's southeast of Fiji. And then you're right, as you said, once we knew that last strip, within 45 minutes, an hour, where it's going to come. And again, even still, there's still a large uncertainty that we know along this line that it's going to fall. But, where on the line, again, by 10 minutes, you're talking about half the Pacific Ocean.
The Chinese Communist Party has shown a long-standing reckless attitude towards space travel. On January the 11th, 2007, China conducted an anti-satellite missile test using a DF-21 ballistic missile launched from the Xichang Satellite Launch Center to deliberately blow up a Chinese weather satellite in order to demonstrate to the world that they could do it. The missile slammed head-on into the 750-kilogram Fengyong FY-1C spacecraft at an altitude of 865 kilometers, traveling at 8 kilometers per second and smashing both spacecraft into a debris field containing literally hundreds of thousands of pieces of shrapnel. The event remains the largest recorded creation of space debris in history, with well over 2,000 pieces of trackable-sized space junk catalogued in the immediate aftermath. And then just last year, another Chinese Long March 5B rocket crashed back to Earth, this one leaving a trail of debris across Africa.
This isn't the first time they've used this rocket, and this isn't the first time it's come down unexpectedly. A few years ago, it was believed to have actually come down over the Ivory Coast and actually hit some things. So, this is part of their design, and this isn't country or China bashing. It's just a bad design. Everyone agrees this is not how you should design the rocket because you end up in exactly this situation.
There've got to be literally millions and millions of bits of shrapnel up there, all moving at 28,000 kilometers an hour as they orbit the Earth. Some the size of rocket boosters like this, others the size of a fleck of paint.
Yeah, that's right. They run the gamut, and they all pose a danger because when you're traveling tens of thousands of kilometers an hour, a flake of paint can destroy something. You don't want to be hit by a screw traveling 40,000 kilometers an hour. So maybe your whole satellite doesn't just disintegrate, but it breaks, and then it's a piece of space junk. And with these big pieces, like this rocket booster, like old satellites, they can break apart into hundreds or thousands of pieces of debris, which can crash into more and more. In fact, just the other weekend when the SpaceX Crew-1 was going up, they had a potential worry of a piece of space junk heading for them, and they had to prep for an evacuation. These things are happening all the time. So as we put more stuff up, we're producing more junk. Now, we're trying to do three things: limit how much junk we put up there, and groups are getting better at it. This isn't the case in this rocket booster. Then start knowing where the junk is, because at least you can potentially tell something that you can control to get out of the way, and then cleaning it up. And this is actually something Australia is doing a big part of with the facilities at Mount Stromlo, using lasers to track and deorbit these tiny bits of debris. And then there's groups building things to capture larger satellites in orbit. So it's a huge body of work, but it also has to start with us not creating more junk, just like on Earth.
Now, this laser technology is really interesting. This was something first developed by Electro-Optics, I think, in Queanbeyan, which is near Mount Stromlo, a couple of years ago. What this does, it's able to track small bits of space junk, but also a more powerful version would be able to slow down their speed as well, and that would help them deorbit. This is small things we're talking about.
That's exactly right. So we've been hosting, so EOS has the laser telescope on the mountain, and we started a joint project between ANU and them to actually build that more powerful laser that was actually just turned on for the first time a few weeks ago. Because if you have enough laser energy, it emits energy, and if you just slow it down, you can actually get it to fall to the Earth's atmosphere and then burn up harmlessly, because that's the name of the game. You want the Earth's atmosphere to disintegrate it or get rid of it. So this is, now that it works, it's a remarkable piece of technology. And again, we're only talking about small bits, but there's millions of these small bits, and those millions can turn into a lot more broken satellites.
Well, there are a lot of problems getting the world to agree to allow this laser to be built, because there must be one or two countries out there that aren't happy about the idea of Australia shooting lasers up at satellites.
Look, it is a joint project with a few different countries, but yes, it is a technology that people want to keep an eye on. But at the same time, everyone knows space junk is a problem. It's one of the few topics that all the countries essentially communicate and agree on and talk to, because it affects everyone equally. And, this just really highlights the scale of the problem. When adversaries or people who don't talk on Earth talk in space, it's a bit of a different problem. And this is exactly what is going on, which is why a lot of people are disappointed to to say the least, in the design of the Long March 5B, because you could just do better. And that's what everyone does. They have purposely these aims to deorbit, and come back down controlled or not even get into orbit, so it's not a problem. Now, obviously, you want to be like SpaceX where it just lands and you reuse it, but you don't want to at least create more issues, and that's exactly what this is. And this is not going to be their only launch. They're planning on building the rest of the space station, which will require more of these rockets to go up, each of which has the same issues. This isn't an isolated event.
Certainly not. And of course, China were the ones who in 2007 used a missile to blow up one of their own weather satellites just to show that they could do it. That itself left what is still the biggest single cloud of debris up there.
That's exactly right. These little bits just get, these streams going around the Earth. And they can crash into more things and more things. India did it a few years ago, much to the demise of the U.S. and Russia as well. It's these things that sometimes we're just not learning. And, it's a slippery slope to show what you can do technologically and advance technologically versus being a bit careless. And there's a lot of pointing of showing the careless nature, let's say, of this last launch.
How concerned are you about a possible Kessler syndrome?
So this is one of the few, a lot of people talk about asteroids hitting the Earth. Yes, they will and do, but we kind of know of that problem and we know how to solve it. Kessler syndrome, though, this cascading runaway effect of space debris is just a real issue. And it's a worry because we're so dependent on satellites. I think that's the thing we don't appreciate is just how dependent on satellites are. If we lose satellite infrastructure and or the ability to put more up because we can't essentially leave the Earth, then we're going to have to change a lot of ways we operate here on Earth quickly and dramatically. And people are not ready for that. And what that then means is we have to solve the space junk problem, but we're not doing it fast enough. And this is what a lot of people point to. It's growing. And you would like to say those who don't study history are doomed to repeat it. We've seen how we polluted some of the oceans and plastics in the oceans and all sorts of things like that. We can learn what we have done here on Earth, and you would think we would do better in space, but we're not.
I remember a scene, one of the opening scenes of the movie Gravity. Now, Hollywood normally doesn't do space very well, and Gravity was an example of that movie. There are lots of things there that I wasn't very impressed with, but one thing I was impressed with was the initial collision which destroyed the space station in the movie. How close was that to reality, do you think, for a Kessler syndrome event?
Look, that's the exact worry, is if you get enough hitting a big piece of debris, then it produces just tens of thousands, which then created a triggering effect. I think the opening scene actually is effective, to be honest.
When I saw that scene, I thought, yes, that's exactly what it'd be.
Now, gravity misses as we have different heights of satellites, so it wouldn't knock out every satellite. But if you're in close proximity, yes, you will get knocked out. And just as you said with that Chinese anti-satellite test, there's a stream of debris that then just gets stuck going around the Earth. It doesn't just float or sink away. It gets stuck in orbit. And it's uncontrolled, and kind of like if you're on the parkway or the highway and all of a sudden you just do a sharp turn across all the lanes, you're going to hit someone. And that's the worry, is that as these cross the paths of everything else that is controlled, they run into them. And so, while obviously it's Hollywood and, a movie, it highlighted in a very, I think, effective way what we really are worried about is that one or two things that is that cascading trigger effect. We say the straw that broke the camel's back. We worry about that piece that breaks the space's back, so to speak. And something like this, if that happened to the space station, besides the calamity and loss of life, it would be, words cannot even describe the issues we would start to have.
That's Dr. Brad Tucker, an astronomer with the Australian National University's Mount Stromlo Observatory. And this is SpaceTime. Still to come. NASA's Ingenuity Mars helicopter begins a new demonstration phase of its mission, and solving the mystery of the length of a day on Venus. All that and more still to come on SpaceTime. After beating all its technology demonstration parameters, NASA's Mars Ingenuity helicopter will now begin a new phase of flight operations, scouting out ahead of the Mars Perseverance rover, searching for interesting geology and the best routes. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California say the 1.8 kilogram rotorcraft will now shift its focus from proving that powered control flight is possible on Mars to demonstrating flight operations that future aerial craft can utilize. This new flight program that Ingenuity's on follows a successful fourth test flight, which saw the helicopter climb to an altitude of 5 meters, then fly south over rocks, sand ripples and small impact craters for 133 meters, collecting images with its downward-looking navigation camera, and then going into a hover while imaging with its color camera, and then returning to its takeoff point near the rover, known as Wright Brothers Field. The flight doubled the range flown, took a record 117 seconds, and saw an increased airspeed of 3.5 meters per second. Ingenuity's transition brings with it a new flight envelope, with more precision maneuvering, greater use of its aerial observation capabilities, and of course, more overall risk. The change also means Ingenuity will require less support from the Perseverance rover team, which is looking ahead for targets to take rock and sedimentary samples in the search for ancient microbial life on Mars. On April the 26th, the mission's 66th Sol, or Martian Day, Perseverance drove 10 meters south to identify potential targets for its first sampling operation. Perseverance project scientist Ken Fairley from Caltech says the 6-wheel car-sized rover will spend the next couple of hundred sols executing its first science campaign, looking for interesting rock outcrops along a 2-kilometre-long patch of crater floor before heading north and then west towards Jezero Crater's ancient river delta, a place where geological sediments and possibly also fossilised microbial life, if it ever existed on Mars, may have washed into. With short drives expected for Perseverance in the near term, Ingenuity could be used to execute flights to land either near the rover's location or, as the rover progresses, at future anticipated parking spots. Perseverance, which transported Ingenuity on its 278 million kilometre journey from Earth to Mars, landed in Jezero Crater back on February the 18th on a mission to search for evidence of past life on the Red Planet. The helicopter can use these opportunities to perform aerial observations of the rover's science targets, potential rover routes, and study inaccessible features, while also capturing stereo images for digital elevation maps. Mind you, the cadence of flights during this phase will slow down, from once every few days to once every 2 or 3 weeks. Mission managers will now assess flight operations after 30 sols and will complete flight operations no later than the end of August. That timing will allow the rover team to wrap up its planned science activities and prepare for solar conjunction, the period in mid-October when Mars and the Earth will be on opposite sides of the Sun, thereby blocking out communications. This is SpaceTime. Still to come, solving the mystery of the length of a day on Venus. And NASA's SpaceX Crew-1 returns safely to Earth. All that and more still to come on SpaceTime. Scientists have developed the most accurate measurement yet of the length of a day on Venus, finding it to be 243.0226 Earth days. The findings, reported in the journal Nature Astronomy, also show that the length of a Venusian day can vary by as much as 20 minutes. Venus is an enigma. It's the planet next door, yet it reveals little about itself. An opaque blanket of thick cloud conceals a harsh landscape pelted by acid rain and baked in temperatures which can liquefy lead. The new measurements are based on 15 years of radar observations, which are slowly lifting the veil on some of Venus's most basic properties, including the tilt of its axis and the size of its core. The study's lead author, Jean-Luc Margot from the University of California, Los Angeles, says Venus is Earth's sister planet, yet these fundamental properties have remained unknown. The thing is, Venus and Earth have a lot in common. They're both rocky worlds born at the same time, under similar conditions, in the same part of the solar system, and out of the same materials. They're both nearly the same size, have nearly the same mass, and virtually identical densities. Yet they've evolved along very different paths. Something happened to Venus early in its history, causing it to rotate in the opposite direction to the Earth and most other planets in the solar system. Fundamentals, such as how many hours are in a Venusian day, will provide crucial data for understanding the divergent histories of these neighbouring worlds. Changes in Venus's spin and orientation revealed how mass is spread out within. Knowledge of its internal structure, in turn, fuels insights into the planet's formation, its volcanic history, and how time has altered its surface. The new radar measurements show that an average day on Venus lasts 243.0226 Earth days. That's 3 weeks longer than the Venusian year, and roughly 2/3 of an Earth year. What's more, the rotation rate on Venus is always changing. A value measured on one day will be a bit longer or shorter than the length of day measured at another time. The authors estimated the length of the Venusian day from each of the individual measurements they made, and they observed differences of at least 20 minutes. Margot says that probably explains why previous estimates didn't agree with each other. He thinks Venus's heavy atmosphere is likely to blame for the variation. As it sloshes around the planet, it exchanges a lot of momentum with the solid ground beneath, speeding up and slowing down its rotation. This happens on Earth as well, but the exchange here only adds or subtracts 1 or 2 milliseconds from each day. The effect's far more dramatic on Venus because the Venusian atmosphere is roughly 93 times as massive as Earth's, and so there's an awful lot more momentum there to trade. Margot and colleagues were also able to determine that Venus's axial tilt is just 2.6392 degrees. That compares with the Earth's 23.5 degree tilt. Based on these measurements, the authors calculated that the planet's core is about 3,500 kilometers across. That's about the same as that of the Earth, although they couldn't tell how much of that is the solid outer core and how much is a liquid inner core. To reach their conclusions, Margot and colleagues used NASA's Deep Space Communications Network's 70-meter Goldstone, California dish to fire radio waves at Venus 21 times between 2006 and 2020. Several minutes later, those radio waves bounced off Venus and echoed back to Earth, to be picked up by Goldstone, and roughly 20 seconds later by the 100-meter Greenbank Observatory dish in West Virginia. The exact delay between receipt at the two facilities provided a snapshot of how quickly Venus is spinning, while the particular window of time in which these echoes are most similar reveals the planet's tilt. This is SpaceTime. Still to come, NASA's SpaceX Crew-1 returns safely to Earth. And later in the science report, a new study has determined for the first time how much the world's glaciers have retreated because of climate change. All that and much more still to come on SpaceTime. NASA's SpaceX Dragon Crew-1 mission has splashed down safely in the Gulf of Mexico, ending the first commercial crew program long-duration mission aboard the International Space Station. The return comes some 6 months after launching aboard a Falcon 9 rocket from the Kennedy Space Center in Florida. The Crew Dragon capsule Resilience docked to the Harmony module's forward docking port at the space station 27 hours after liftoff. The mission also marked the first night splashdown of a manned U.S. spacecraft since the Apollo 8 pre-dawn return to the Pacific Ocean back on December the 27th, 1968.
So in the next phase of the mission, Dragon has a series of steps to complete before returning Mike, Victor, Shannon, and Soichi home. First, Dragon will maneuver to the correct attitude and then start to separate its claw, then jettison its trunk, which is the cylindrical, unpressurized part of the spacecraft. The trunk is currently connected to the aft or bottom section of the Dragon capsule, where the heat shield is located. So in order to expose the heat shield and get the vehicle ready for atmospheric re-entry, we'll jettison the trunk.
From there, the spacecraft will use its forward thrusters to perform a deorbit burn, which will put Dragon on a trajectory to return to Earth. The burn will last more than 16 minutes once it starts.
And to prepare for these upcoming events, right now the Dragon capsule is doing a number of things autonomously. It's isolating the thermal control system fluid loops from the radiator. This system is what will help keep the internal temperature of Dragon for Mike, Victor, Shannon, and Soichi nice and cool during re-entry. Dragon is also initiating separation of the claw mechanism, which will terminate data, power, and fluid connections between the capsule and the trunk.
Crew Dragon and its trunk now separate, flying free, and we are just moments away from hearing the beginning of the deorbit burn. And right on time, we also have the start of the deorbit burn. As we mentioned, this should last 16 minutes, 26 seconds. So this has fully committed Crew Dragon to coming home. We are in the entry, descent, and landing phase of the mission. Once Crew Dragon really begins its entry into the Earth's atmosphere, we anticipate a loss of signal for about 7 minutes, where we won't be able to receive telemetry or data or video or audio from the Crew Dragon vehicle. The reason for that comms blackout is because plasma builds up on the outside of the capsule due to the speed at which the vehicle is re-entering the Earth's atmosphere and building up that heat to around 3,500 degrees Fahrenheit outside the capsule.
SpaceX, we show deorbit burn is complete with nominal performance. Nose cone closure initiated.
And SpaceX from Resilience, we copy all. That's great news, and we're following the nose cone closure.
And that is great news. The deorbit burn completed successfully, and now we're moving on to nose cone closure. In the background right now, Dragon is currently inhibiting those forward bulkhead thrusters that we just used to complete the deorbit burn, ensuring it's safe to latch the nose cone shut for re-entry. So as we begin the second half of entry, Dragon is now beginning to flush nitrox into the cabin and continuing to top off Mike, Victor, Shannon, and Soichi's suit with cold air. Again, this is what will allow the cabin temperature to remain comfortable while external temperatures reach over 3,500 degrees Fahrenheit. The heat shield is pointing forward, the bottom, so to speak, of the capsule, leading the capsule into the landing site. And the suits themselves can detect if they start to get too warm and will automatically start drawing in that nitrox, again, to keep the astronauts nice and cool all the way down until splashdown. And weather continues to look great, excellent, if I may say. Wind speeds are very low, and the height of the waves are also very low. There's no rain in the area, so really ideal conditions for splashdown and recovery of the crew. Once they splash down, there are a couple of boats that will step in to make sure that the area is safe. They'll collect the chutes, and then there is a larger recovery vessel that will come up and scoop Dragon out of the water, hoist it using a crane on the back of the boat onto the deck, and then we have a couple of checkout procedures to get through before we open up the hatch, and medical staff can start to attend and evaluate how the astronauts are doing before they, eventually get into the helicopter and start to make their way back towards land.
Dragon SpaceX, we show nose cone secure for entry.
And SpaceX from Resilience, we see the same.
We just heard that Dragon is in entry attitude, exactly where they need to be. And for this targeted splashdown off the coast of Panama City, Florida, we have that loss of signal that we predict to occur coming up in about 1 minute. And we expect to see that last for about 7 minutes. Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi all on board Crew Dragon, returning home today. We're standing by for that LOS under 100 kilometers in altitude. Altitude of Crew Dragon now at 90 kilometers.
So again, a lot of things are happening pretty rapidly here. And the first set of parachutes will deploy. They are drogue chutes. They are conical in nature, and their job is to stabilize and begin sort of the initial deceleration of the vehicle, followed very shortly after by the main parachutes. There are 4 of them.
Dragon SpaceX, com check.
And SpaceX, this is Dragon, over 4Gs, 42 kilometers.
SpaceX, we have you loud and clear. Expect automated chute deployment.
And Resilience copies. We are at 40 kilometers, 4.34 on the Gs.
That's Commander Mike Hopkins reporting the Gs that they experienced upon reentry. And as you heard, we are now out of that loss of signal portion, meaning the plasma has eroded away enough from the spacecraft.
I think my heart skipped a beat as soon as I heard the crew responding back. And
Dragon SpaceX, a GPS is converged. Expect nominal altitude for drogue chute deploy.
Resilience copies. Nominal altitude for drogue deploy.
Crew Dragon Resilience now 30 kilometers over Earth. It's quite a quick drop over that 100 that we saw just a few minutes ago. Those 2 drogue chutes should deploy at 18,000 feet in altitude. Crew Dragon will be moving approximately 350 miles per hour.
Dragon SpaceX, recovery team reports visual.
Good news. We're at 20 kilometers. Seats are rotating.
SpaceX copies on the seat rotation.
And those seats are rotating into the proper landing position. We saw them a little bit more reclined earlier, facing the top of the capsule, and now they are more forward-facing towards that side hatch.
SpaceX from Resilience, we show good drogues.
SpaceX copies and concurs nominal descent rate on 2 drogues.
2 drogue chutes have deployed. Everything looks nominal, and we're slowing the Dragon vehicle down. We are expecting the 4 main chutes to deploy within the next minute.
Visual on 4 mains.
And Resilience copies, and we see a nominal descent rate.
SpaceX copies and concurs nominal descent rate.
4 main parachutes, slowing the vehicle down to what will be about 16 miles per hour prior to splashdown just off the coast of Panama City, Florida.
We show you just under 800 meters, still good descent rate.
Just under 800 meters from the Earth, that's about half of a mile, and we are tracking splashdown.
And 600 meters, and we're showing 10 meters per second on the descent rate, a little higher than nominal.
SpaceX copies.
And SpaceX, we show nominal descent rates, 200 meters, brace for splashdown.
SpaceX copies, brace for splashdown.
Seconds away from splashdown, everything nominal aboard Crew Dragon Resilience returning to Earth.
And there are the boats starting to chase after Dragon to begin their recovery operations as soon as Dragon lands. And I don't know if you can hear the applause, but we have visual confirmation of the Crew-1 Resilience capsule.
From Resilience, this excellent news. We are splashed down. The pyros have fired. We're water.
SpaceX copies and concurs. We do see mains cut as well.
And we have successful splashdown. The main chutes have also cut as well. The fast boats are now making their way towards the capsule to begin the recovery operations. Again, that first boat is going to start to inspect the capsule and make sure that there isn't any residual toxic fumes in the air.
Dragon, on behalf of NASA and the SpaceX teams, we welcome you back to planet Earth, and thanks for flying SpaceX. For those of you enrolled in our frequent flyer program, you have earned 68 million miles on this voyage.
And SpaceX Resilience, it is back on planet Earth, and we'll take those miles. Are they transferable?
And Dragon will have to refer you to our marketing department for that policy.
A bit of levity from the crew and the core.
And that splashdown coming at 11:56 p.m. Pacific Time, 6:56 GMT.
During their mission, Crew-1 contributed to some 250 scientific experiments. Among other things, they looked at protein crystal development for new drugs, testing robotic assistant technologies, growing crops on station, and looking at new ways to produce semiconductor crystals. Crew-1 astronauts also took part in 5 spacewalks, connecting cables on the recently installed Bartolomeo science platform, preparing for the space station's new solar arrays, servicing the orbiting outpost cooling system, and completing several external maintenance tasks. Last month, all 4 Crew-1 astronauts boarded the Resilience for a docking port relocation maneuver, moving their Dragon spacecraft from the forward-facing port to the space-facing port aboard the Harmony module. That move allowed the forward-facing port to receive the new Crew-2 mission, which arrived on station on April the 24th. Later this year, SpaceX's next Dragon commercial resupply mission, its 22nd, is scheduled to dock to the newly vacated Zenith port, bringing with it the first pair of new space station solar arrays. Following splashdown, Resilience was returned to SpaceX's vehicle processing facility at the Kennedy Space Center. Now known as the Dragon Lair, it's the same building where the space shuttles used to be serviced between missions. There, the spacecraft will be carefully inspected, systems replaced, and prepared for its next mission. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has for the first time worked out how much the world's glaciers have retreated due to climate change. Using data from NASA's Terra satellite, scientists were able to measure the total melt of the planet's 220,000 glaciers, not including the Greenland and Antarctic ice sheets. The findings, reported in the journal Nature, show that between the year 2000 and 2019, the world's glaciers lost an average of 267 billion tons of ice every year. Scientists also found that the loss of global mass accelerated sharply during this period. For example, between 2000 and 2004, glaciers lost 227 billion tonnes of ice a year, but between 2015 and 2019, the lost mass increased to 298 billion tonnes annually. The glacial ice melt caused global sea levels to increase during this period by some 0.74 millimetres per year, with nearly half due to the thermal expansion of water as it heats up. A new study warns that invertebrates are declining globally in both diversity and abundance. The findings, reported in the journal Austral Entomology, suggest potential serious consequences for ecosystem functioning. Scientists found many Australian butterflies are imperiled or declining, but few are listed for protection by legislation. The authors identified the 26 Australian butterflies at most immediate risk of extinction within a 20-year time frame. They found the Australian fritillary and pale imperial hairstreak topping the extinction risk list. Paleontologists have identified a new species of hadrosaur or duck-billed dinosaur at a dig site on Japan's southern islands. The findings, published in the journal Scientific Reports, suggest that Yamotosaurus izanaki migrated from Asia to North America rather than the other way round as previously thought. Scientists also found that the herbivores evolved from walking upright to walking on all fours. The remains were discovered in late Cretaceous strata, dating from around 71.94 to 71.69 million years ago. Hadrosaurs are often thought of as the cows of the age of dinosaurs. Reaching lengths of 8 metres and weighing as much as 8 tonnes, they've become the most commonly found of all dinosaur fossils, being discovered everywhere from North America and Europe through to Africa, Asia and Australia. A new study reported in the American Journal of Clinical Nutrition found that whether it's espresso, latte or decaf, your genetic code could be what's driving your desire for coffee. A study of 390,435 people by the University of South Australia found casual genetic evidence that cardio health, as reflected in blood pressure and heart rate, influences coffee consumption. The authors found that people with high blood pressure, angina and arrhythmia were more likely to drink less coffee. They were more likely to drink decaffeinated coffee or to avoid coffee altogether compared to those without such symptoms. Mainstream news outlets have gone after COVID-19 conspiracy theorists with a passion, and that's good. But when it comes to other science topics, it seems they have no problem ignoring scientific evidence and promoting conspiracy theory nonsense. And that's bad. The problem is the major media organisations don't employ specialist science journalists in their news departments. Sure, niche programs do, but they're busy working on their own shows. So it's left to general news reporters, who usually do the police rounds and local politics, to cover it. And the problem is they usually don't know the first thing about science, and so they usually end up doing a really bad job. And the editors who are supposed to sub their work and correct their mistakes are just as scientifically ignorant. It's not their fault, it's just a specialist field and it's one they know nothing about. Tim Mendham from Australian Skeptics says all this causes confusion and ends up fueling the public scepticism of science more broadly. And that's bad.
Yeah, there was quite a scathing article in a recent edition of the American Council on Science and Health. The trouble with the media is they're not very consistent in their support of scientific thinking. They say, let's follow the science of medicine about COVID, etc., even though some of them are even there a bit dodgy. But in other areas, they regard science as an anathema or as a problem rather than as a solution, whether that's science, medicine, or whatever particular area you're looking at. And so the classic case is media response in some cases to climate change, where the media that are saying, follow the science as far as COVID, are then suddenly saying the science is rubbish as far as climate change, even though the science is equally well supported in both cases. It's an area of contention. It's an area that's linked to politics, obviously, and a whole range of different conditions. But the suggestion is that the media really probably needs to lift its game and have some sort of consistency, please. Journalists make mistakes. That happens, obviously, especially when you're talking about complex science topics, but an out-and-out position taken by some media that sort of totally is inconsistent is a worry. What then do you believe in the media? Which means a lot of people who end up distrusting the media. There is no consistency.
I can't believe that. Oh, dear. Distrusting the media. What we're seeing, I think, is media are trying to get listeners or viewers or readership. And in order to do that, they're catering for an audience. And what's happening is they've found their niche markets that they're going for, and they're pandering to those markets. Those markets are very comfortable hearing the news they want to hear. They don't necessarily want to hear the truth. They'd rather hear hear news that makes them feel good.
Niche audience, your sort of echo chamber audience, which just agrees with everything you say.
And that's what we're seeing globally with media, which makes it really hard when you're actually looking for someone who's going to report stories and present stories to you in a completely dispassionate, factual way. And the problem gets even worse when you're dealing with a topic as complicated as science and medicine. There you really do need specialist reporters. And these days, very few media organisations have those specialist reporters in place.
Yes, it's true. I mean, you could probably count the number of full-time science reporters on one hand in Australia. Leaving outside medicine, there's probably a fair number of journalists who cover medicine, but a lot of the people sent out to cover science are not scientists. So, you're relying on people who are learning on the job.
On Channel 10 the other night, I saw a newsreader there talk about dinosaurs existing 2 billion years ago. I almost fell off my seat when I heard that. 2 billion?
2 billion. Life wasn't exactly the most complicated thing.
So eukaryotes.
Yeah, it took a long time for multicellular. But yeah, no, I mean, the scientific literacy, I remember a newsreader once talking about, I think it might have been Voyager or something, going out past one of the moons of Jupiter, which was named 10. He meant Io.
Interesting story with that. They were originally going to call the Alien movie Io. That was the first of the Alien movie franchise. And they changed the name to Alien because everyone thought they meant 10. Just thought I'd throw that in there. Carry on. Sorry about that.
Scientific literacy is not the best, so is historical literacy is not the best. There's all sorts of areas where people are prone to things and they're not helped by media which is inconsistent and can throw up any old idea of 2 billion-year-old dinosaurs. You just got to shake your head and think, well, should you rely on these people? But news media is having a hard enough time it is, so they're trying to do clickbait and all sorts of ways to attract a particular audience. It's sad. It's a fact of life. Can you say it shouldn't be? Because it shouldn't be. Do you find the best sources? You should, and there are decent sources out there. You just got to do a little bit of work to find them.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.